Hello everyone, this is Sir Said, and today we are going to solve paper Feb March 18, paper 1-2, and let's start. In question number 1, the question is which unit is equivalent to the coulomb. So to get the unit for the coulomb we have two relations. Number 1, I is equal to Q by T, then Q is equal to IT, means ampere second. But this option is not given here, so we have to choose another relation. V is equal to W by Q, then Q is equal to W by V. The unit of W is joule, it's work done, and the unit of V is volt V. So joules per volt. That's why option B is correct. For question number 2, which row shows a quantity and an incorrect unit, not the correct, incorrect unit. Efficiency, yes, correct, no unit. Moments of force is Newton meter. Moments are you can say R into F, so its unit is Newton meter, not Newton per meter. So it is the incorrect unit, that's why this is the right option. Now question number 3. In this we have some two forces are the coplanar forces. Coplanar means the forces acting in the one plane. The direction of one force is in this way, east, and the direction of other force is in this way, it's north. So to get the resultant of these two forces, the resultant vector must be in between. It's called R. So to balance this resultant, an equal and opposite force is required, and it must be in this way, this one, and it is in between west and south. So this balancing force is in between west and south, and it is equal and opposite to the resultant. So what is the direction of the single force that will balance these two forces? Is the force which is towards southwest. So option D is correct. Now for question number 4, the density of the papers are given. Typical sheet of paper has width 210 and its length is this one. In this book we have 500 sheets and the thickness is 50. What is the mass of a single sheet? Not the mass of the whole book is required. So suppose we have a book like this one, this way, this one, and this is the length of the book, and it is 300 millimeter. The width of the book is 210 millimeter, and the thickness of the book is 50 millimeter. So by all these dimensions we are able to get the volume. The volume is in fact length into width into height. And to get the mass, you know the relation, that is density is equal to mass over volume, then mass is equal to density into volume. So the value of the density is 800 kg per meter cube. The unit is kg, and if we convert all these units to the standard SI units like the density have, then it will be easier, but the mass will be in kilogram, and then we will convert into grams because the answers are in grams. So to get the volume, we have 210 into 10 is per minus 3, that is 50 into 10 is per minus 3, and that is 300 into 10 is per minus 3. this is the mass of the whole book, but the mass of the single sheet is required, so we have to divide this whole mass with 500 to get the mass of single sheet, and this mass will be uh, let me calculate somewhere. Okay, by using the calculator we come to know that the mass is 5 gram, so option B is correct. The theory behind this question, that there is a book, length, width and height of the book is known, so you can get the volume, and multiplying the volume with the density you will be able to get the mass of the whole book, and the mass of one sheet is required, so divided it with 500 sheets, the total number of sheets, so you can get the mass of one sheet and convert that mass into gram is 5 grams, so option B is correct. Now moving towards question number 5. This question number 5 is related with the percentage uncertainty. So to get the percentage uncertainty, you have to divide the uncertainty with the actual value. So for the potential difference, you know that V is equal to IR, and you know R is equal to rho L over A, and I is equal to rho L over area is pi d square by 4. We always talk about the cylindrical wire, so the area is pi r square and we convert into pi d square by 4. Anyhow, while getting the percentage uncertainties, this 4 is ignored because it is a constant, and to get the pi ignored as well, it is constant as well. This and this are ignored while getting the percentage. So we have to write the percentage uncertainty of I, rho, L and d square. For I, the percentage uncertainty is 0.5 into 100 by 5, and for the diameter it is 0.1 into 100 by 0.8, and for the length it is 5 into 100 by 150, and for the resistivity we have 0.2 into 10 is per minus 8 into 100 by 1.6 into 10 is per minus 8. But we have to solve it in terms of a power factor, this density having power 2 and all other values having power 1. If we multiply all these with 1, this is multiplied with 1, this is multiplied with 1, but this is multiplied with 2 because this is the diameter of the wire. This d is the diameter. So when you put all these values in calculator, you come to know that this has the most biggest answer. So option B is correct. Question number 7. Question number 6 is not here because it is now out of the syllabus. A stone of mass m is dropped from the tall building and air resistance is not ignored. It means air resistance is considered. The acceleration of free fall is g. When the stone is falling at a constant speed or terminal speed means zero acceleration. So which is the correct one? So we come to know that the acceleration is 0. Option A, B, C, D, in all these the acceleration is 0. Okay, fine. The magnitude of the force of gravity on the stone, if the force downward is mg, then almost a force F which should be equal to mg is acting upward, so the resultant force is 0, hence the acceleration is 0 and the velocity is constant. The magnitude of the force of gravity on the stone is this one, this is the weight, so this and this are the remaining correct options. Magnitude of the force of air resistance, this one must be mg, so option B is correct. It is simple question. Question number 8. Question number 8, when you have the velocity time graph and the part of the graph is below this axis, the horizontal axis, it means we are talking about the displacement because the direction is reversed. So this area give you some displacement, means the body is moving in this way, and over here the body is moving backward in this way. Let me clear this line and we'll draw it again. So it is coming back, you can say, in this way. So this is area 1 and this is the area 2. These areas are equivalent to the displacement. So if we subtract these two vectors, this is the answer, because now you have to get the total displacement. So these two displacements are subtracted with each other and this is the total displacement. Hence option A is the correct option. Now in question number 9, a girl throws a ball vertically upward. It takes 3.20 seconds to return to her hand. It means if we throw the ball like this one and then this ball comes down to her hand, the total time is 3.20 seconds. Initial velocity is to be required and the final was 0 at the top. It means the time to go up and down is 3.2. So when it reaches at the top, the time is half of this value. It is 1.6 second. So the time is known. We may use v is equal to u plus 80. This v is 0, u is required, moving against the gravity, so minus a is replaced with g and the time is 1.6. So u is 9.81 into 1.6. By substituting the values, you come to know that the answer is this. So option D is correct. It's question number 10 here. A steel pellets, each of mass is this one, fall vertically on the top of a horizontal plate at a rate of 100 pellets per minute. Means if we have a plate here on the surface and we have some steel pellets like this one, and the mass of each pellet is 0.60 gram, and these pellets are going to fall and hit on the surface, and 100 pellets are going to hit on the surface in 1 minute. It means the 100 pellets each having mass 0.60, this is the total mass which is going to fall on this plate in 60 seconds. So this is in fact m over t, that is mass over time. Now they strike with the velocity of 5 meter per second and then rebound with the velocity of 4, means the momentum is going to change. And now you have to find the average force. It is simple. Average force is change in momentum over time. It means mv mu over time. If we take mass as a common factor, then v minus u over t, but m is equal to m into v minus u over t is the correct formula, because one negative sign is for the change in the momentum and the other negative sign is for the direction, because the direction is reversed. So in fact these are going to add. Hence m over t and v plus u. M over t is given, that is 100 into 0.60, but this is gram, so we convert into kilogram. 10 is per minus 3 and the time is 60 and the velocity is 5 and 4 is 9. So by substituting all these values, you come to know that the answer is 0.0090 Newton. That's why option C is the correct one. Moving towards question number 11. For the question number 11, which row describes the resultant force and the resultant torque? For the resultant force, the sum of upward forces is equal to the sum of down. So making sense, the upward force is 40, downward 45, and the downward is 45. But the sum of rightward forces is equal to the sum of left. On rightward we have the total 60 Newton, but on the left we have no force. So the resultant forces is non-zero, option A and B. Now, to get the resultant torque, if this is considered to be the center and the distance from the center is considered to be moment arm, then this force will rotate in this way, this force will rotate in this way, means clockwise, in this way, but this force will rotate in this way. So we have three clockwise forces and one anti-clockwise forces, and it's very clear by the magnitudes the sum of clockwise is not equal to the sum of anti-clockwise, so the resultant torque is non-zero as well. That's why option A is correct. Next question is question number 12. It is not included because it is the question related with the electric field, which is not in AS now. For the question number 13, in which example it is not possible for the underlying body to be in the equilibrium? An aeroplane climbs at a steady rate. Maybe it is in equilibrium aeroplane. Maybe the up and downward forces, the backward and forward are balanced, so it is in equilibrium. An aeroplane tows a glider at a constant altitude. Constant altitude, maybe the forces are balanced. A speedboat changes direction at a constant speed. If the speedboat is going to change the direction, even the speed is constant, means direction is changing, so the acceleration is not constant. If the acceleration is not constant, then it is not in equilibrium. So option C is the correct one, because you know that to get the equilibrium, the resultant force, that F is equal to ma, must be equal to 0 for the equilibrium. And you know that mass never be 0 and A is 0. If A is 0, means A comes from the speed plus direction. So if the speed is changing, the acceleration is changing, and speed is changing, the velocity is changing, direction is changing, the velocity is changing. If any one of these two quantities or both are changing, means the velocity is changing, hence the acceleration will not be 0. So the velocity is constant, its speed and direction is constant. If speed is changing, velocity is changing, direction is changing, velocity is changing. If velocity is changing, then the acceleration will never be 0. And if acceleration is not 0, the resultant force is not 0. Resultant force is not 0, the body is not in equilibrium. So in all these examples, it's not possible for this speedboat to change its direction, but the speed is constant and still in equilibrium. It's not possible. Question number 15. In question number 15, the car has mass 1100 kg traveling at a steady speed of 15, yes, and it's moving up the slope horizontal. The combined frictional force acting on the car are directed downward, and this force is W by F, where F is the weight of the car. What is the useful output power of the car's engine? It means if it is moving in this way uphill, this angle is 10, and this car is moving in this way, then two forces are acting downward. One is the component of its weight, like this is mg, and this is angle, so this is called mg cos theta, and the force acting in this way is mg sine theta, and another force is acting downward in this way, and this is w by 5, the frictional force. So the sum of these two forces must be in the opposite direction to get the equilibrium, because the speed is constant with the same direction. So we know the relation P is equal to Fv, and this F is the sum of these two forces, that is W by 5 plus mg sine 10. This is the force multiplied with 15 meter per second. So by substituting the value, the mass is 1100 into 9.81 by 5 plus 1100 into 9.81 into sine 10 and multiply with 15, and you can get the final answer is 60 kilowatt. Hopefully you get the logic behind this question. When the body is moving uphill with the angle of 10 degree and it is moving with a constant speed, means zero acceleration, the upward and the downward forces along the line plane, inclined plane must be equal. So W by F and mg sine theta are acting down the slope, and the same magnitude must be up the slope. So we add these two forces and multiply it with the speed to get the power. In question number 15, we have a lamp here, and the lamp is 60 watt. Lamp converts 95% of its energy into heat. Okay, 95% into heat means this is actually the waste energy, because it is a lamp and the light should be the output, which is 5%. Okay, so we get 5% of this 60 into 5 by 10 is equal to 3 watt. So 3 watt is the 5%. But here we have a modern lamp, this one, and its power is 4 watt and has the same power output of light. Okay, it means this lamp is providing 3 watt as output. What is the efficiency of the modern lamp? So you know that if 3 is the useful output and the rating is 4, multiplied it with 100 to get the efficiency, then answer is 75%. In this question, the old lamp is 5% efficient, so out of 60, only 3 watt is coming as a light. And this modern lamp has the same power output as a light, so it is 3 watt, and its total input is in fact the 4 watt, so the efficiency is 75%. Now question number 16. In this question, the bead is released from rest. It means at this point its kinetic energy is 0 because it is at rest, but it has potential energy, which is mgh. But when this bead is rolling down over there, at this point all of its potential energy changes to kinetic energy, but again it is getting some height and come over here at point Q. At point Q it is moving, so it has kinetic energy plus potential energy. It has both energies over here. And air resistance and all the frictional forces on the wire are negligible. You have to get this height. So at top we have this potential energy, that is mgh, and the kinetic energy is 0 at point P. But at point Q it has kinetic energy which is equal to half mv square plus its potential energy is mgh, and h is 40 into 10 raised per minus 2 meters. So if we get the m common from right side, then we can cancel this m on both sides. Now h is required, so h is 0.5, v is 1.4 square plus 9.81, it's g, and 40 into 10 raised per minus 2, and this whole divided with 9.81. By calculating this, we come to know that h is 0.50 meter. So this is the answer. For question number 17, a small diesel engine uses a volume of 1.5 tons per 4 centimeter cube of fuel per hour to produce a useful output power of 40. It means the volume used is 1.5 tons per 4 in 1 hour, in 60 minutes, 3600 seconds, but the output obtained is 40 kilowatt. It may be assumed that 30 kilojoule of energy is transferred to the engine when it uses 1 centimeter cube of the fuel. What is the rate of transfer from the engine of that energy is wasted? It means the output and the inputs are not equal with each other. So first of all, we have to get the input. 1 centimeter cube give you the energy of 34 kilojoule. This is given, and if we use 1.5 into 10 raised per 4 centimeter cube of volume, then the energy E is the input. So by cross multiplying these two things, the energy is 510 and then 000 kilojoule. This is the input, and if we get the power, then it is 510,000 divided by 3600, means this energy is delivered in 1 hour. So the obtained energy, this is the input energy, I've already calculated it, it is 142 kilowatt. So 142 is the input energy, which is actually coming from this volume. 1.5 into 10 per 4 centimeter cube of the fuel is burned, the diesel is burned, and get the power of 142 kilowatt. But not all of this power is used, only 40 kilowatt is used, and the remaining is the waste one. So the wasted energy per unit time, means the power, is 142 minus 40. The answer is 102 kilowatt. That's why option A is correct. These two questions are a little tricky, little lengthy. Question number 17, if you try to get some basic understanding of this question, in this question 1.5 tons per 4 centimeter cube of volume of the diesel is used to produce the power of 40 kilowatt. It never means that all of this volume is used to get the power of 40, because the remaining one is wasted. So we get the input and subtract it from the output, we can get the waste one. So moving towards next question. This is question number 18. In this question, two forces are we have two boxes. X and Y have the same mass. This one, the box S is lifted vertically through height of h by a force of magnitude F. Box Y is pulled along a slope by the force of same magnitude, reach the same height as shown. So in this question, it is not written that while moving the inclined plane there is no frictional force. It means there are some frictional forces. Both boxes gain the same amount of gravitational potential energy and same amount of work is done by the two forces. This is correct if the situation is ideal and the work done is equal to the gravitational potential energy. But in B, both boxes gain the same amount of gravitational potential energy. Yes, right, because same height. But more work is done by the force acting on Y. This force is bigger than this force, so this is looking correct, because more force is required over here, because some extra work is required to overcome the opposing forces which is along the inclined plane and some frictional forces, and that's why this is the correct option. Option C and D both are wrong, because the gravitational potential energy is not less in both these cases, same, and gain not more or less, it should be same or equal. That's why option A and D are correct, and B, A is wrong as well, because this is not ideal situation. C, D and A, these three are not correct. For next question number 19, this question is very simple, that this is force extension graph, and at which point in the graph does the metal wire stop obeying Hooke's law? You know that from Hooke's law, F is equal to KE, then K is equal to F over E, means for the force extension graph the gradient must be constant. So the gradient is constant up to point A. That's why up to this point the Hooke's law is valid and not after this. Okay, for this question number 20, this is a model crane in which a load is attached with a cable. This is a crane, and in this question the material used for each part of the model is same as that in full scale crane, so the materials are same. The model is 1/10 of the original size, so you have to get the stress in the cable on the full size crane and the stress in the cable on the model crane. So while solving this, you may write it as sigma is equal to F over A, means stress is equal to F over A. This stress is equal to force, that is mg, and the area is length into width, and you know that mass is equal to volume into density. So mass is length into width into height, and by substituting m, length into width into height into rho into g divided by L into W. So LW is cancelled with LW, and you are left with sigma, and the sigma for the model crane is again h into rho into g, but g and rho are the constant, their values are not going to change even in the model, but the h is reduced to 1/10 of its value. So if we divide sigma with the sigma model, it is rho into g into h divided by rho into g into h by 10. So these are cancelled with each other and we are left with 10 by 1. So 10 is your answer. Option C is correct. Thank you very much and good luck.